guys, welcome back to another video, and today we're going to be learning 2.4 quotient rule, chain rule, and trig function derivatives. So let's get started with the quotient rule. So the basic form of a quotient rule is you're going to have d over dx of your two functions over each other. And we've learned product rule already, but we haven't learned if something's divided by something, how to even take that derivative. So, the basic way and formula to memorize is this. Low d high minus low d high minus high d ho over ho ho. Now what does this even mean? It means you're going to take the low. You have your low. What's your low? G of x. So you're just going to put g, and then what's d high? Derivative of your high function. So f prime minus high. What's high? Just f. Derivative of ho, low, which is g, right, multiplied, all over ho ho, g squared. And that is your quotient rule formula. So this is what you're going to need to memorize to take derivatives of things that are over each other, and you can implement this formula to do so. Now let's do a quick little example. So if we're going to have f equals x squared minus 1 over x to the fourth plus 1. This is going to be pretty darn tricky, but we're going to do our little technique. So ho, derivative of high, which is 2x, minus high, just by itself, derivative of the bottom, 4x cubed, all over the bottom squared. Now, this is good as it is. You can multiply them together and simplify if you want, but this is all you really need to do quotient rule. So yeah, you can try some examples on your own, but this is all you need for now. Now, we're going to get into our chain rule, and then afterwards we're going to have our trig functions. So let's start, let me get rid of this, with our chain rule. So now this is going to get really tricky when we're going to have chain rule, trig, quotient rule, all mixed up together for your test that's coming up. So it's really important to know how to use and think about all three at once. So now we're going to move on to chain rule. So chain rule, what it's basically saying is, if you have, it was always tricky for me learning it in the first time, but if you have f of x equals the square root of x squared plus 1, and you go to take the derivative, you have to also, for a moment, pretend that this inside is just x, right? And you ignore the inside to take the derivative. But then you have this x squared plus 1 in the middle, and you have to also account for that. So you have to take the derivative of the outside of the function and then multiply the derivative of the outside of the function by the derivative of the inside of the function. So this definitely doesn't make sense right now, but I'll show you and I'll work through this problem, and then you might be able to understand a little better. So I always like to do this so I can think about it better. I can use our exponential rule by making the square root to the 1/2. So now I can think, alright, well, I'm going to multiply this to the front. Keep the normal function the exact same. And then I'm going to have to subtract 1 from the top. It's negative 1/2. But now we're learning quotient rule today. So now we have to multiply this whole thing by the derivative of the inner function. Okay? So what's the derivative of x squared plus 1? 2x. 2x. So now our final answer is going to come out to be 2x over 2 x squared plus 1 to the negative 1/2. And these are going to cancel out, and that's all you need for your answer, really. But you can always simplify the negative exponent. Let's do one more quick example before we move on to trig functions. So if I have problem f of x equals 2x squared plus x in this function. So we have to recognize our outer function. Our outer function is just 1/2 x cubed. Okay? This becomes 3/2 x squared. But we know our inner function isn't just x. It's 2x plus x. So you can plug that in for x. 2x squared plus x. And what do we have? Squared. And then derivative of the inner function, which is going to be 4x plus 1. And that's your little answer right there. So that's how you do quotient rule. And now, for the end of this video, we're going to move on to trig derivatives. So I'll stay down here. So, trig derivatives, you're just going to have to straight out memorize. It's something you're just going to have to bite the bullet and learn how to do. Here's what we're going to do. There's a big, long formula where you can really derive them from the limit and the derivative formula, but I'm just going to give them to you straight up, and this is what they're going to be. So derivative of your sine x becomes cosine x, because if you plug this into the, h plus h minus 1 over h sort of limit thing, it's going to come out to cosine of x, and that's what's going to happen with all of these. So you're just going to have to memorize them, get used to them, and then you'll be able to just have them in your head, and you can always use them. And there's going to be chain rules with them, which we'll do in a minute. Secant squared x. So tan x is going to be secant squared x. And then what's secant x? It's going to be secant x tan x. And then you're going to have cotangent x and CSC x. And the good thing, I'll tell you a little bit of some tricks how to memorize these. So the good thing about these things is that they have patterns to help you memorize. So one of the patterns is all of the C's have a negative in front, if you've noticed. All the C's have a negative in front. These two are similar because they're inverses of these two. And they both have the function multiplied to, the respective cotangent. And once you get used to these, they'll all work out very easily. But let's do some chain rule and some basic example problems. So if I give you the function f equals 3 cotangent 2x squared, and you derive that, go ahead and pause the video, try it yourself. It's going to be 3 negative 3 CSC squared of 2x squared times the chain rule, which is 4x. Boom, you're done. That's your answer. Thanks for watching.